Internal storage is a vital component of any computing system, responsible for holding data and software that the device needs to operate. It is categorized into two main tiers: primary storage and secondary storage, each serving a distinct purpose in the computer's functionality. Primary storage, also known as memory, is fast and volatile, such as random access memory, RAM. It holds data and instructions that the central processing unit, CPU, actively uses. However, primary storage is not permanent. Its contents are lost when the power is turned off. Secondary storage, on the other hand, is non-volatile and provides long-term storage for operating systems, software, and user files. This storage tier is slower but crucial for retaining data even when the computer is powered down. Internal secondary storage typically takes the form of either hard disk drives, HDDs, or solid-state drives, SODs, each offering unique characteristics and advantages. Hard disk drives, HDDs, are one of the most common types of secondary storage. They rely on mechanical parts, including spinning platters coated with a magnetic material and a red write head that moves across the surface to access or store data. When data is written to the drive, it is stored magnetically on the spinning platters, allowing it to be retained without a power supply. HDDs are valued for their large storage capacities, often measured in terabytes, TB, and their cost-effectiveness, making them an ideal choice for users who need to store significant amounts of data, such as videos, photos, or software. However, the mechanical nature of HDDs makes them relatively slower compared to newer technologies and more susceptible to physical wear and tear. The moving parts create latency as the read-write head seeks the correct position on the spinning disk, and they can also be vulnerable to damage if dropped or exposed to shock. Despite these drawbacks, HDDs remain widely used for tasks where high capacity is more important than speed, such as archival storage or bulk data management. Solid-state drives, SSDs, by contrast, have no moving parts and represent a more modern approach to internal storage. Instead of relying on spinning platters and mechanical heads, SSDs use flash memory to store data. This form of storage is entirely electronic, with data stored in integrated circuits that can be accessed almost instantaneously. The lack of mechanical components means SSDs are faster, quieter, and more durable than HDDs. They can read and write data at significantly higher speeds, making them an ideal choice for applications that require quick performance, such as gaming, video editing, or running complex software. The advantages of SSDs extend beyond speed. Their compact design and resistance to physical damage make them particularly well-suited for laptops and portable devices. Additionally, because they generate less heat and consume less power than HDDs, SSDs contribute to the energy efficiency and longevity of computing systems. However, these benefits come at a higher cost per gigabyte compared to HDDs, which can make SSDs less practical for users with extensive storage needs unless combined with other solutions. Together, HDDs and SSDs provide a range of options for internal storage, catering to different user priorities such as capacity, speed, durability, and cost. Modern computing systems often use a combination of the two, with an SSD serving as a primary drive for the operating system and frequently used applications, while an HDD is employed for secondary purposes like storing large files. This hybrid approach allows users to enjoy the best of both technologies, balancing performance with affordability and storage capacity.